Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math questions out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 235. On page number 235, and today is our lesson number 118. Today we'll deal with the concept of slope. What is it? What does it measure? What does it measure? And for those of you who have been watching my videos on a regular basis, you will know that I already covered this topic once before in my geometry videos. And if you're interested in watching that video, just type in, this is a tag that you want to type in, just type in geometry for GRE. One more time, geometry for GRE, day 10, will pop right up. Watch that video, you might learn, you might get something out of it. Because a lot of people, if you ask them what is the slope, they will give you the formula, delta, change in y over change in x, or rise over run, they would say, Americans. But they have no idea as to what it means conceptually. They memorize, they go around memorizing rise over run. What the hell does it mean? You want to understand the concept behind it. So what does slope measure? What does slope measure? Very simple, very straightforward answer, very straightforward question, to which you should be able to give a very simple, very straightforward answer, a cogent answer. Cogent answer, a convincing answer, a persuasive answer, instead of simply saying it's a rise over run. What the hell does it mean, rise over run? It doesn't mean anything. What does slope measure? Slope measures the steepness of a line. Slope measures the steepness of a line. That's all it is. That is all it is. It tells you how steep a given line is. That's all. That is very simple. The steeper the line, I'm not sure if it requires article in the beginning. I'm not quite sure about it. The steeper the line, the greater the slope. For example, I'm going to draw two lines. Here is our line 1 and here is our line 2. Line 1, line 2. Just by looking at these two lines, L1 and L2, which one is steeper? Of course L1 is steeper. So therefore L1 has a bigger slope. That's all it is. L1 has greater slope because what I meant to say, L1 has a greater slope than does L2 because L1 is steeper. That's it. A lot of the time when these kind of questions appear on the exam, they give you 5 different graphs and or one graph with a bunch of different lines and simply asking you which line is the greatest slope. A lot of the times you can answer that question just by visual inspection, but you do have to understand one concept which we're coming to in a second. Okay? Let's cover that concept right now actually. Let's cover that concept right now. So here, actually it's too early for that. We'll come to it in a second. The next thing we have to understand is that a line is said to have positive slope if what? What does it mean for a line to have positive slope? Positive slope simply means that when x goes up, then the value of x goes up, the value of y goes up as well. And when x goes up and when x goes down, the value of y goes down as well. In other words, both x and y move in the same direction. When x goes up, y goes up, and when x goes down, y goes down. I'm going to show you here in this example. This line here is a positively sloped line. Let's start the journey from here. Let's call this point A to make it interesting. And we're going to go to point B. We're going to start our journey from point A and we're going to go to point B. What happens to the value of x? The value of x goes down. The x coordinate goes down. As you can see clearly, the value of x coordinate is going to go down. Because the value of x coordinate is going down, you can clearly see that the value of y coordinate also goes down. The value of y coordinate also goes down. Similarly, if we were to start our journey from B, what happens as you go from B to A? As you go from B to A, the value of x coordinate goes up. The value of x coordinate goes up, and therefore the value of y coordinate goes up. We are at point B, it has certain y coordinate, and as we go up here, the value of y coordinate goes up. As you can clearly see, they move in the same direction. When x goes up, the y goes up. When x goes down, the y goes down. That's all it means. It means they move in the same direction. Let's talk about a situation of a negative slope. We need a lot of room, so I'm going to erase most of this stuff here. So what does slope measure? It measures the steepness of a line. Slope tells you how steep a line is. Steeper the line, greater the slope. Let's talk about a situation of a negative slope. A line is said to have a negative slope a line is said to have a negative slope if when x goes up, y goes down. When x rises, when x coordinate goes up, the y coordinate goes down. They move in the opposite direction. And similarly, and when x goes down, y goes up. They move in the opposite direction. They move in the opposite direction. We'll see what a negatively sloped line looks like. Here is a line that is negatively sloped. It has a certain coordinates. Point A. Let's go from point A to point B. What happens as we go from point A to point B? The value of x coordinate goes up. As you can see, the value of x coordinate is here somewhere and it's going to go up. The value of x coordinate goes up, and as a result, the value of y coordinate goes down. The y is going down here. The drop in y coordinate is this much. Similarly, if we were to start our journey from point B, and go to point A, going from point B to point A, the value of x coordinate would have gone down. Let's put it in the red ink so you can see that. The value of going from B to A, the value of x coordinate would have gone down, and as a result, the value of y coordinate would have gone up. As you can see clearly, they move in the opposite direction, and such a situation is called a negatively sloped line. A negatively sloped line. So, now the next question. And if you watch this video, where it talks about geometry for GRE day 10, on which I covered the concept of slope, and after day 10, there are some problems that I do, which ask you different questions about the slope. Watch all of them and make sure that you understand how questions are presented on the exam. Because it's a very simple concept, but the way they phrase the thing, the way they present to you sometimes is a little tricky. Anyway, let's move on to the next part. How do we measure slope? That's the next question. How does one measure it? How does one measure slope? Slope tells us how much does y change. Slope tells us how much is the change in y. How much does the y change for every 1 unit change in x. For every 1 unit change in x. For example, let's give it a coordinate here. Let's pretend that this is 2 and 7. And let's pretend that this is 5 and 1. The y coordinate of b is 1, y coordinate of a is 7. So, how much did the y change here? How much was the change in y here? The change in y was, going from a to b, was 7 minus 1. And this is how we write it. Slope measures how much is the change in y, the delta. This is read as delta for the Greek letter D. You have alpha, beta, gamma and delta, the fourth letter, same as our D, A, B, C, D, which represents the change. It's a traditional, conventional way of representing a change. It has to do with differential equations and so forth. Differential comes, they use delta. This is a small letter delta, that's the capital letter delta. And we typically use capital letter. So, change in y here, the change in y going from a to b, the change in y is 7 minus 1. 7 minus 1. The question is, the y changed by 6 units. 7 minus 1 is 6. Y changed by 6 units. But for how many for how many units change in x? Did the y change by 6 units when the x changed by just 1 unit? Or did the y change by 6 units when the x changed by 1,000 units? We have to know how many units change in x. Let's see. It was 2 before, now it is, x was 2 before, now it is 5. So the change in x is 3. 5 minus 2. Or rather, not 5 minus 2, you see? We caught ourselves. It's not 5 minus 2, we're going from A to B. Listen carefully. A to B. Because you see, if you were to continue here, this would have been 6, this would have been 3, this is a positive quantity. But as you can clearly see, this is a negatively sloped line. We need a negative quantity. That's how I caught myself. So again, one more time, we're going from A to B. Going from A to B, the change in y is 7 minus 1. And change in x is not 5 minus 2, but it is 2 minus 5. 2 minus 5. 2 is our initial point, b is our final point. So it's 2 minus 5. Which is going to give us our negative 3, which is going to give you finally as negative 2. The slope of this line is negative 2. What does it tell you? How do you explain to this in English language, the slope of negative 2? What does it tell us? The slope of negative 2, tells us that for every 1 unit increase in x, y decreases by 2 units. I'm going to read it one more time here. What it says, slope of negative 2, slope of negative 2, which we just found here. A slope of negative 2 tells us that for every 1 unit change in x, if x changes by 1 unit, if x increases by 1 unit, I and c is increased. For every 1 unit increase in x, y would decrease because they are negatively sloped, because the line is negatively sloped by 2 units. Now, as you notice, I left some room here. Similarly, it also tells us that slope of negative 2 also tells us that for every 1 unit decrease in x, for every 1 unit decrease in x, y would increase by 2 units. That's all. If one decreases, the other one would increase. If one increases, if x increases, the y would decrease. They move in the opposite direction. By how many units? By 2 units. That's what that 2 tells you. For every 1 unit change in x, the y will change by 2 units. For every 1 unit change in x, the y will change by 2 units. So if the change in x is 5, change in y is going to be 10. And which way though? Well, that has to do with the negative slope, which means if x increases by 5 units, y will decrease by 10 units. If x increases by 2 units, y will decrease by 4 units. I hope I said it right. I have no way of reminding it right now to listen to it, so I do not know. But anyway, that was it. Let's do the problem that they give you in the book. Enough of the talk, let's do the problem now. We are ready. The problem that they give you in the book is 2.8.1. That's what I want to do right now. 2.8.1. Where should we do it? Let's do it right here. I'm going to read it to you. It says, in the xy plane, the slope of the line passing through the points, so they give you 2 points here. Points are Q, which is -2, -3, and R, +4 and -1.5. What is the slope of this line if the line goes through those 2 points? Well, that's again very simple. The slope, and by the way, the symbol that is typically used, conventionally used in the mathematics book for slope is M. Don't ask me why. That's just a convention, that's just a norm, that's just a tradition. That's what the mathematicians use to represent slope, M. So M here, the slope, equals the change in y over the change in x. How much is the change in y here? Well, it's -3 minus a -1.5 over -2 minus +4. And that boils down to -3 and -1.5 is -4.5 over -2 and -4 is -6. And negatives and negatives from the top and bottoms are going to cancel each other out. So basically it boils down to +4.5 over 6. And I don't like this 4.5 business, so I'm going to convert this into multiply top and bottom by 10. And if you multiply top and bottom by 10, it becomes 45 over 60. And of course, 45 over 60, if you divide the top and bottom by 15, it turns out to be 3/4. The slope of this line is 3/4. That's all. Very simple, very straightforward. Now it does not matter which point you start out with. You can treat this as the initial point, you can treat that as the final point, or you can do vice versa. It's just going to change the order here, but because the order is going to be changed in top and bottom, they're going to wash each other out. So the slope of this particular line in example 2.8.1 at the bottom of page 235 is 3/4. That's all. We are done for today. I will see you tomorrow when we will continue this concept of slope. but obviously I'm not going to talk about it in this much detail. We did it twice and that's enough. Twice because I already did it once long time ago in my geometry videos, which is this part is already mentioned 2 or 3 times. Just type in geometry for GRE day 10. Particularly if you are weak in geometry, if you need to practice some more questions, these videos will probably help you. I will see you tomorrow. Okay, bye now.